Boiling points, like I have been saying for a really long time, it all has to do with the hydrogen bonding that they can do. So when you have nitrogens that have hydrogens attached to it, so maybe you have primary or secondary amines, those can hydrogen bond with the other amines in there. And the interaction is going to be between the hydrogen of one nitrogen and the lone pair of the nitrogen of another, a different molecule. And if you have this hydrogen bonding, the boiling point of the amine is going to be higher. Of course, we have to remember that the nitrogen-hydrogen bond, this hydrogen bonding is weaker than the hydrogen bonding of alcohols. So if you were to compare the boiling point of an amine with the boiling point of an alcohol, the alcohols would still have a higher boiling point. Now, tertiary amines, they have 3 alkyl groups attached to them, so they don't have any hydrogens. Tertiary amines are going to have a lower boiling point because they cannot hydrogen bond. In terms of solubility, depending on how many carbons you actually have on your amine, and the number for amine seems to be 6. So if you have less than 6 carbons, the amine is going to be water soluble. Anything above 6, then you're going to have an insoluble amine. And it is all based, again, on the hydrophobic interactions. Hydrophobic interactions are based on how long the carbon chain is. The longer the carbon chain, the less soluble the compound's going to be. And also branching, if you have a methyls or ethyls on the carbon chain, that actually increases the solubility. That's something that we actually saw in the first semester too. Now, most amines, unfortunately, very unfortunately, they smell like rotten fish. This one right here, notice I have 1, 2, 3, 4, 5 carbons in between, and I have a nitrogen on each side. So the name for this is 1,5-pentane diamine, but it's also called cadaverine because that's the actual smell. So I'm not going to tell you what it smells like, but hey, there you go. Now this is perhaps what I would think it's the most famous amine ever. You would think nicotine is famous, but that was so 70s. Cocaine is now more famous. And when we talk about the solubility of cocaine, or we talk about the solubility of any amine for that matter, what we're looking for is whether the nitrogen is positive or if it does have a lone pair of electrons. This right here is cocaine hydrochloride. Notice the nitrogen is protonated, so it's going to have a positive charge, and every positive charge has a counter ion, so I have a chloride right there. If I take this and I neutralize the hydrogen chloride, I deprotonate my amine, I am going to get my tertiary amine back with my lone pair, and this is what they refer to as the free base, cocaine free base. To actually deprotonate an amine, I'm going to need a base. So sodium hydroxide or sodium bicarbonate will do it. If you want it to go this way, if we want to protonate the amine, then we add HCl. And it's a matter of actually just playing with the solubility. If the compound has a charge, then it's going to be soluble in water. If the compound does not have a charge, like this free base right here, it's going to be an oil, and it's going to be insoluble in water. So that's how you get your cocaine hydrochloride, and then you can go free basing it when you're neutralizing the HCl. Now, strangely enough, amines can also be acids. Of course, if an amine is going to be an acid, then I'm going to have a really strong base in solution. Butyl lithium or any other carbon, negative carbon base, it's going to be a really strong base. So the butyl lithium, let me go ahead and draw it. I just like to draw it. This carbon is a strong base, stronger than a nitrogen, so it's going to deprotonate the nitrogen. Now this nitrogen on the right has two lone pairs of electrons. One was originally on it, and then I deprotonated, and it has now two lone pairs, so the nitrogen is negatively charged. And of course, every negative deserves a positive, lithium. And this is lithium diisopropylamide. And this is what we call LDA. We have used it before, and now we know how to make it. Of course, for us, nitrogens are going to be basic. So let's talk about the basicity of amines. If you have ammonia and you put HCl on it, ammonia is going to go and pick up the proton from the HCl. It's going to deprotonate HCl, and it's going to form your ammonium chloride. All amines are going to be able to do this as long as there's a lone pair on the nitrogen. So it doesn't matter if you have a primary amine, a secondary amine, or a tertiary amine. They can all be protonated to the ammonium salt with an acid. It doesn't need to be HCl. It just needs to be an acid. All right, that's the end of the first part of the amine chapter. Go ahead and listen to the second part.